Good. Welcome everyone for the last and final meeting of the Israeli School on Biometrics. For the last 7 meetings, we discussed different aspects by different people, from introduction to biometrics till, I think, things like biases last week, irises, fingerprints, deep fakes, and all of that. And of course, presentation attacks. And we wanted, Aaron and I, to wrap up this school by trying to look forward. And for that, we have gathered 4 panelists. 2 of them gave talks during the school, and you met them, Professor Sebastian Marcel and Professor Adam Chizeka, which we'll introduce again in a second for those of you who weren't around. And they are joined by John Callas. I will do the full presentation in a second, and by Naama Ben-Zvi, who is the Israeli head of the Israeli unit for biometrics and identification. I keep on missing the order of the name in the formal name, so we'll do the formal introductions in a second. Aaron, would you like to say some more?
Yeah, thank you, Or, and thanks to the panelists for accepting the invitation, and thanks to all the attendees as well. The school has been a success despite all the circumstances. Really appreciate the engagement from the attendees over the past several weeks. There were some excellent lectures, and I believe the attendees have learned a lot about biometrics and also the challenges in biometrics. And now as we enter this final session, I think it's a great opportunity for you and the others to ask questions of our panelists. Of course, they will be giving some opening comments and addressing some questions that Or will be posing at the beginning. But this would be a great time to think of questions related to biometrics, not just based on what you have seen over the past several weeks in this course, but also in terms of future aspirations of biometrics and future concerns about biometrics. And so we have 4 excellent panelists. They are the right people to field these questions. So we look forward to a rather involved session. With that, I'll hand this back over to Or to do the formalities and introduce our esteemed panelists.
Thank you very much, Arun. So today with us, we have, I'm reading it according to the screen that I have, Professor Sebastian Marcel. He is mostly known for his work on presentation attacks. This is also the topic that he covered in his talk. He's coming from Switzerland, from the Université de Lausanne, and from the IDEAP, which is a big research company in the topic of biometrics. He was associate editor of the IEEE Transactions on Biometrics and Identity Sciences. He published numerous papers, very influential papers, and he worked on the topic. Sebastian, the floor. Sorry, I will first introduce everyone, and then we'll open the floor for the presentations. Then John Callas. John is a computer security and technologist expert. He worked on many topics when it comes to the topic of security and privacy, mostly on things in the Internet Engineering Task Force, these things like OpenPGP or DKIM, those of you who know these technologies, and ZRTP. He used to work at the ACLU, the American Civil Liberties, ACLU. So everybody knows the ACLU, I forgot the U. John will have the opportunity to fix me. And the Electronic Frontier Foundation, where he was quite a senior technology advisor over there. Continuing, we have Professor Adam Chizeka from Notre Dame University. He's an expert in irises. He gave a wonderful talk. Those of you who haven't seen it are mostly encouraged to go and see it again. Sorry. He won numerous awards, including the NSF Career Awards. He collaborated with the US Department of Defense, the US Army, the US National Institute of Justice, the FBI, etc. And you can see his full CV on the website. And last but not least, we have Naama Ben-Zvi. Naama is the Biometric Commissioner and the head of the Identity and Biometric Applications Unit, which is part of the Israeli National Cyber Directorate, which is part of the Israeli Prime Minister's office. I've known Naama for many years. She's been working a lot, I think, in the units almost from the day one. That maybe she correct me afterwards if I'm wrong. But day one, the first time I heard of the unit, she was already there. And in October 1st, 2023, she became the head of the unit, officially a bit later, but because of some reasons that you probably know. And since then, she has been with the unit. I will open the floor for opening remarks, and I will start going backwards. Naama, the floor is yours.
I'm the first one. Okay, so I've prepared a short presentation. Forgive me, it's not the most sophisticated one, but I'm still going to share it. Just share screen. Can you see it?
Yes, we can.
Wonderful. Thank you. So, or you were very accurate in my presenting my biography. I'm in the field of biometrics for the past, I think, 14 years or so. I'm not a professor. I have a master's in law, and I'm a system analyst, a certified system analyst. And I've been studying this field, this very interdisciplinary field, for the past 14 years. So usually when I give a talk about biometrics within the government or outside, I put on this photo, which I assume you all know. Sometimes people in the crowd are too young to remember, or to even been born back then. But this is usually how I started. Now it's a very triggering image, maybe these days, but still, I know we're going to talk about the future of biometrics, but I'm bringing you back around 20 years or so to the 9/11 event, which was a very pivotal moment for biometrics. Basically, in three impacts that I'd like to mention. So the first one is disaster victim identification. Basically, this event really impacts all the DNA research mainly. I don't know if you know, but the United States is still identifying victims from that disaster till today. The DNA research and the automation of the process, which is basically a biometric process, was very much developed since then. This is the first impact. Of course, here in Israel, since October 7th, that's our 9/11. Things have progressed also in that area, but we're not going to go into details. It's a very morbid area, so we'll leave it at that. Then you have border control, which I'm sure you all know that was highly developed or amplified after 9/11. Basically, the United States began its big and huge program around biometrics and collection of biometrics and the usage of biometrics at the border. Something that was basically done in the areas of forensics and policing and military sometimes, but now was basically used with the vast majority of the population in a very civil application mainly. So this was the second very significant impact, and also the NIST, the National Standard Institute of the United States, developed major programs around standardization of biometrics and so forth. And then we have the anti-money laundering process or laws, the know your customer process, which is also a very significant impact since 9/11, where the usage of biometric identification or verification was brought a few years later for us to actually identify who holds the account and to prevent money laundering problems also around terror organization, not only around criminal acts. So these were the three main impacts from that pivotal moment or event that really made a difference in the biometrics area. But what happened since from 9/11 till today? So I would say around the disaster victim identification, there are research made around other modalities that are not really in use around identifying the deceased, like face and iris, and I know of other research done around that. So this is something that is happening these days. We have major applications or usage. More databases are being created. You have around the border control scenario. You have the EES program of Europe, which is the regulation passed a few years ago, but the application is delayed. But it's due to happen at the end of this year, where third country nationals will have to give their biometrics to Europe, including us Israelis. Also, we have a new Israeli law around biometrics from third country nationals. And so this is a vast impact that we are seeing that is continuous until today. We have a basic trend around frictionless. We have face recognition, which is very, very much here and here to stay, apparently, and is a very powerful tool around the border control and more modalities. But I would say face recognition is the very, the major tool that is being used. And we have plans around digital passports. So this is the trends that we are seeing in the past few years and in the new years to come. And then we have major challenges around the know your customer process. So we've seen that face recognition is being vastly used around those processes online, but we are also seeing peaks in fraud. We have presentation attacks and replay attacks and deepfakes attacks, and I'm sure Sebastian is going to talk about around that.
אתה יכול שנייה להקשיב להודעה ששלחתי לך?
Yes. Guys, if you can mute yourself, so because we can hear you. So these are, if you can see in the green rows here, we were seeing the major trends or impacts for what we're seeing today, the past few years, and the years to come. But we're going to talk about future biometrics today. So I don't know how long I have, so I'm just going to present the next slide in which I wanted to focus, and that's our digital persona and biometrics. Okay, and this is a subject that we can connect to the last two items that we saw before, the border control scenario and the know your customer scenario, and basically who we are online and how biometrics is involved in that. So first, I would say that facial recognition is something that is being vastly used around the online process and also in border control, and also by governments around the world when they construct their databases. But what we're seeing today and in the next few years is that face recognition is no longer a silver bullet like we previously thought. Maybe some of us were a bit skeptic, but today we can definitely say this is we can see it as an anchor, and I do believe it would stay as an anchor in the online process or in other biometric process. But this is not enough. It's not enough to establish a process that we can rely on to be reliable. So what are the things that will happen for us to make sure this is a reliable process, and what are the possible trends around that? So I would say, first of all, basically AI, this is just, I had to say AI in this presentation, so I'm dropping the AI word, is a friend or foe. So it's a friend because it allows us to do all those things that in a better way than we used to know how to do. But it is also a risk around deep fakes and other fraud process. So how do we mitigate that, and what is the place of biometrics around that? So this is the last slide. These are the four topics I'd like to touch around that topics. As you can see, I've marked two topics with a question mark because I'm not sure about that. But there are two topics that I would definitely say is the mitigation that we're seeing today in the next few years. So on the right side of the screen, you can see results of a survey done by the Biometrics Institute last year, where 81% said that deepfakes pose a significant threat onto biometrics, of course online, because on real life, in the border procedure, if you come in a physical attendance, it's not really a threat. But we are living in the virtual world of the online mostly. And then what would be the mitigation? So 22% said last year that they presume there would be other modalities that would have to be forward in order to strengthen the process. I mean, because face recognition is not good enough, then you should add more modalities. So this is a possible trend that we can see, that we might see, but this is something I've put a question mark around that, because as I don't know how much you feel when you go into applications and you have to wait a very long time, or when you have a really not a very friendly experience around applications. People are basically very impatient around waiting or around malfunctions, and adding another modality is it's very complex. So this is the reason I'm putting on that question mark. It depends on the application, I would say, but I'm not sure that would be the answer. We came to see that there are research around the possibility to extract two modalities from a one shot taken. Let's say, how about combining facial recognition with iris in one image? So this is a question, and this is an R&D challenge. I'm saving the privacy challenges for last, or don't worry. So this is a first question. I mean, how do you reconcile the need to other modalities with your desire to have frictionless process and not to make your clients agitated? So I'm not sure this will be the answer. The other thing that we're seeing is usage of soft biometrics and complex fraud detection. So it's not enough to have a very strong process with face recognition, because this could be breached. So we would see development of our other selves, our digital selves online. And that could be combined, well, that could combine soft biometrics that we already know of. I mean, we know of your scrolling technique or your typing technique, but that could be also your geolocation, and also other your behavior online that would be mapped to create your digital self. So we would know throughout the session that this is you, Arun or Yasmin or all of us here online. Is it really us? So this is something that would have to be developed in a much rigorous way in our back office, in the back office of applications, for us to rely on the process, because recognizing our face is not good enough anymore. We do have development of presentation attack detection, and we do have deepfake detection. We do have those tools that are being placed today and have been placed for the past, let's say, 5 years. But we already see that they also have those error rates. And if you want to make your process stronger and be more confident around it, I would say this could not be enough, and you would have to develop your alter ego, your digital alter ego, in order for that process to be successful. Finally, my last question mark is around government ID. The question mark is not around the issuance of government ID, is around the possible collaboration between the private sector and governments around the issuance of the ID and the transfer the ID to the digital era. Just a small example, we've seen that LinkedIn, which is a social media network that began to use uploading government ID to verify our accounts. So for now, it's an option. You can either do it or not. But this is very interesting to see that you go back to the government issuance of ID in order to strengthen other processes. So this is also a question around digital wallet that I'm sure you all know of. Governments are developing digital wallet, but you also have digital wallets by Google and by iOS. And there's a question around collaboration with governments around that. And all that brings us, of course, to our major concern or challenge, how you mitigate or how you balance between the idea or the goal to have a reliable process and privacy concerns. So I wouldn't say this is something that that I have a solution to. This is something that would have to develop, going on, seeing all those trends and trying to find the right balance. But this is basically the challenge that I see that we're facing in the next 3, 4, 5 years. I won't presume to see furthermore than the next 5 years. Also, we have operational challenges around it, and we have some R&D that could be developed around those challenges. This is it. This is my pitch. Thank you so much. So I'm giving you back the mic.
Thank you, Naama. We'll move very quickly to Adam because we don't have much time. Adam,
Sure.
the floor is yours.
I will try to be very quick. So, well, first of all, I do hope that everyone is safe and your families are safe. That's probably what we're praying for these days. My opening will be very maybe unusual and very short. So I don't have slides, which is good. So I'm the glider pilot, licensed glider pilot, but it's not to show off. It's just to say something about what flying taught me. And one of the things that flying taught me is that I have to take full responsibility for my decisions. I can blame the control tower. I can blame my colleagues on the ground, on the radio, if something goes wrong. But at the end, I'm the responsible. I'm piloting the aircraft. I'm making decisions. I keep the stick. And I think it's very analogous to the research, right? So biometrics is now stronger and stronger as any other research area. We're trying to make it more accurate, more faster, better, working, generalizing better on unknown samples and so on and so on. The question is, what are the consequences? Well, we can think about different consequences, but my opening message is that we should, in addition to making a great research and making all these algorithms more and more accurate, we could also think what impact it has, right? And if this technology can, at some point, maybe not only help humans, but also harm humans, and how we can actually counteract this. That's something that maybe is obvious, but it is something that I'm thinking more and more frequently when I'm getting older and more senior researcher. So that's my message. I wanted to be really brief, and I will be happy to, of course, answer all the questions that you have.
Thank you very much, Adam. John, the floor is yours.
Yes, I mean, similarly, I don't have any slides, and there's a lot of issues with biometrics, and simply naming the field itself covers a wide variety of technologies, a wide variety of use cases, and we lump them together as if they're all the same thing. And there are biometric things that are accurate enough, work well enough, and seem not to have a lot of problems. And then there are lots of them that lower in accuracy. We have threats to them, and exactly how you use them isn't always explained well to a user. I mean, for example, we now have on our personal devices, like our phones and the things, biometrics that are really, it's a local biometric that is in a closed loop with a device that then uses device attestation to then go and do conventional cryptographic authentication, etc. So the biometric is a local opener of a non-biometric system underneath it. And those have relatively few privacy concerns. They work extraordinarily well. And then there are ones that are more difficult to do, such as, it's like know your customer across a network, so on and so forth, where the accuracy will go down, and the chances for both false positives and false negatives, and what that means for when things move outside that system, particularly when the biometric data moves between different entities. So it's difficult to talk about it as a broad subject. And the real thing that I think we keep coming back to is this the correct solution for the problem at hand? And that means analysis that is threat modeling on both sides. It means asking what the real goal of what you're doing, because it's easy to throw biometrics at something, particularly where the lay people will say, oh, that makes sense, but it turns out not to be as good as you'd think it would be. And we need to think about those as we are building them, rather than put it in place and then think of the social consequences afterwards. I'll go on from there and give that to the next person.
Thank you very much. Sebastian?
Yes, thank you for having me. So I just would like to reflect on the on the future of biometrics, and maybe more looking at the research aspect of it, right? So I mean, we can discuss about many things: ethical aspects, privacy, legal aspects, and the research side. I'd like to focus on the research aspects, and the way I like to structure that statement would be around three use cases, right? So three research directions that would be driven by three use cases. Some of them have been mentioned during the previous presentation, during the first presentation actually. So the first one would be fraud. So as you know, one of my field of research, one of the biggest field of research is presentation attack detection and also deepfake detection and so on, which is basically detecting fakes of various kinds. And so I've been working in this topic for quite a long time, a bit more than 15 years by itself, although I've been in the field for 25 years, in the field of biometrics. Time flies, and still there are many problems which are unsolved, and especially in this domain of security and detecting attacks. So in fraud, and especially in this use case, growing use case of KYC, know your customer, where people are self-enrolling, and somehow you want to verify the identity against a document that can be itself fraudulous. So the attacks, and not only presentation attacks, have potentially can find, let's say, a surface which is much more important, because it becomes much easier for people and for attackers, imposters, to create attacks. And then the scientific problem that comes with it is the generalization problem. So when you have detectors that can detect, that have been trained or fine-tuned to detect some kind of known attacks, come the day where someone comes with something new, right? So this is a bit always the harm race, viruses and antiviruses. You have always someone that is going to come with someone new, something new, a new way to form an effective attack. So how do you generalize to unseen attacks? So that's one of the research direction that I think is still important nowadays. So detecting unseen attacks. I'm not pretending to have the solution. There are different ways to attack the problem, obviously. There are some ongoing efforts relying on foundation models for that type of tasks. So this is quite new, and we'll see how it goes. The second use case or scenario is, let's say, is more focusing on border control. So, and in particular, there is I see also a new use case growing, which is essentially identification on the move. So verification or biometrics on the move at borders, and more. When I say more on the move, I'm not only talking about the pedestrians in a regular, let's say, airport. Just talking about people that will be traveling, crossing the border in their car, in coaches or buses, these kind of things. And we need to have fast ways to authenticate, to verify the identity of people. And then comes the interesting problems which are connected to the first use case of KYC, is that sometimes you have scenarios where people are going to self-enroll with a selfie, and then you are going to have a face or any other biometrics which are going to be self-enrolled. But at the border, you are going to have other type of sensors which are going to capture the face, maybe with other type of sensing technology. For instance, near infrared deployed at border, because you need to be able to see throughout the glasses or the windows, and or maybe even at night. So you have an heterogeneous problem, and how do you do, for instance, face recognition in heterogeneous settings? How do you compare, for instance, color-based face image to near infrared or the type of sensing technologies? So that's the second one. And then the third one that we'll keep is, and repeating this one, is testing, testing, and testing. So, so this is something you should not forget. I mean, quite regularly, I'm talking to companies and or even government agencies, and I'm astonished to discover that they are not testing, or they are not relying on anyone that has done testing. So just taking for granted whatever accuracy or the performance of the technology they are buying. So, and one of the main reasons is that there is often a lack of not only skills and operational capacity to this testing, but it's also sometimes you just don't have the data. So there is you don't have the data in order to do this test, either because you don't know how to create it. First, you may not have it, you don't know how to create it because you don't have the skills. And sometimes simply because this is a new scenario. So that explains why you don't have the data. So how do you do testing in this kind of scenarios? And then here comes again maybe a research direction that would be to invest on technologies, so deepfake for goods, I would say, to create synthetic data that on demand could create synthetic data reflecting a specific use case you want to test, offering the capacity therefore for an agency to do testing in specific scenarios. So that's the end of my statement. Thank you. I will be happy to take questions.
Thank you very much. And while you're more than welcome to write your questions in the chat, I will start with the first question to start the discussion rolling, which is, and I think that Nama touched it a bit, and then John also, everybody mentioned it a bit. We are discussing what is going to be the greatest problem of biometrics. What is the thing that we need the most to solve? So if you have any more comments on that or thoughts about that, we would be very happy to hear. Let's start with you, Sebastian. I mean, besides of research, what should we solve first?
Okay, so everything should be solved first. That's a very difficult question. I don't know if I have the right answer to that. And in particular, if I have to make a choice, I don't know how to make a choice. So I am interested by everything. So of course you make choices. So at the moment, we have a strong interest looking into foundation models, actually, because these type of foundation models have a kind of, let's say, a nice understanding of, they are nice world, the models. They are modeling the world somehow, to some extent. And since they have seen so much correlations, right? They have very nice zero-shot learning capabilities, which makes them very good at, or give a lot of potential for using them in tasks such as detecting unseen attacks, for instance. And also something that we are trying to explore is the capacity also to create explanations that may be plausible for assisting humans in decision-making process. So if there will be one research topic in which we put the attention, this will be into this. Looking at how to use these foundation models, how to distill them, how to reduce their complexity, because complexity is a big issue. I mean, they are pretty easy to use, and might not be possible to deploy them on the edge, for instance. So there is a lot of interesting research challenges around those models. So if you force me to choose, voila.
John, the same question. You're allowed to nuke biometrics, and sorry, nuke is today not the best word, but you're allowed to say that you had enough with some companies, not pointing fingers at anything that starts with Clearview and ends with AI. But what is the biggest issue with biometrics that you think we should address?
I think it is the philosophical questions. It is the legal, ethical, privacy questions of what we're doing and what we're using them for. Because as I said before, there's so many different biometrics that we tend to lump them together. There are some incredibly useful things that are not useful for others. I mean, for example, lots of us use voice control systems, and a lot of the voice control systems have in them the recognition of different voices, but of course, replay attacks, etc. You don't even worry about those sorts of things, because what you really want to be able to do is to have a system respond to a request like, play my favorite music. And recognizing a person for that is a biometric, but we don't really need to worry about a lot of the edge conditions. And then there's things like border control, where there's not only a huge privacy component, and there's also huge accuracy needs. And those are the things of the appropriateness of the technology to the task at hand becomes the biggest question. And it's really important to get that right up front, so that you don't spend a lot of time building the wrong thing and having that have unfortunate consequences that are hard to get rid of.
Thank you very much, Adam.
It's me now, right? Okay. So again, it's hard to pick probably one thing, but again, if someone would force me to pick one topic, I think it's still related to privacy and respect to others. And we know how to create fake biometric samples for decades. We have been having a lot of fun doing this, but recently with all the generative AI, it's much simpler. Biometric, like synthetically generated biometric samples, are better and better. We have a lot of fun with this. The question is how the data of people who whose data was used in training of these models is actually protected, because these models can leak identity information, can even just give you a copy or almost exact copy of training data samples. So the question is how to protect those who agreed to give us biometric data to train these models. And it's not an easy task. Even if we just go into mathematical details, it's probably, someone could probably prove mathematically that it's impossible to protect this data to be, leaked outside of the model. But maybe we can at least reduce this probability. So that's probably something that I would point as maybe, if I would have to pick one technical issue maybe that we should focus on, I think the privacy of data used in training, especially training this generative AI models, that would be something that I'll probably work on. And I'm working on, actually. I'm interested in that. So I will end here.
Michael?
Some notice that I have issues with my microphone, so I hope you can still hear me. I will try to do something. In the meantime, Aaron will continue the hosting.
Or we can hear you very well now.
Okay, good. Okay, so Nama, the floor is yours.
Yes, so I thought that I would talk a little bit about face recognition in public places. I think we should all know that it's going to be introduced next year in Europe after the AI Act would go into effect. But basically, I would say that how to see the problem, I think the problem is very clear, at least to me, okay? So on the one hand, you want to use it in order to prevent crime or to seize criminals. On the other hand, you have a very major privacy issue. And we would see next year if the AI Act really introduces the right balance around it. We don't know yet. And around that, there's an oversight issue because the AI Act presents a model of oversighting, which is also unclear up until now how it's going to work. So this is something I would say that we would encounter next year in a more significant way, and there's a big question mark around that. But still, I would roll back to my presentation in the beginning of our session. I think that if you look at the philosophical aspects of our personality or who we are, I think our digital self, or the regulation of the digital self or alter ego or avatar, I don't know how you want to call it, is a much more complex philosophical challenge that I would see. And also, I think it's if I would go broadly, if we would look at on privacy concerns, I think that in general, there's a question around how we describe privacy around our, if we look at our expertise around biometrics, because as a person, I also have a right that my ID or identity won't be taken. So how do I balance my right to preserve my identity online with my privacy concerns? And this is a conflict that I presented before, that if we want a reliable process, we have to create something that would be centralized, managed centralized, and we would have to define our digital self and monitor it on one hand, and on the other, this is basically it diminished our possibility as a private citizen or person to control our identity or our privacy concerns around how my digital identity is being monitored. So I would say that from a philosophical point of view, this is something that is not even addressed. I mean, the facial recognition in public places was addressed, and we would have to see if the model is good enough, if the balance is good enough. This is an issue that I think has not been thought of yet, not thoroughly. So I would say this is the challenge that I would see in the next few years.
I see. So this is a reminder to everyone. You can write comments in the chat, questions to the panel, and we will ask them. So if I would try to connect a bit what Adam mentioned before, and I think it also touches the privacy issues. We saw the deployment, and as Nama mentioned, we're going to see more deployment of facial recognition in public spaces, but now we're starting the discussion about privacy. Now we're discussing the discussion about, do we gain something out of that? And going back a bit to what John said, that we need to distinguish between the users, which let's call them personal users, which are local, versus the public users. And, again, there is a difference between when I go through passport control and when I go in the street, and I have different expectations for privacy in those environments. And did we again reach the point, and I know that everybody, especially today, but this is the standard point of reference in these sort of questions, is this like nuclear weapons? We first develop nuclear weapons and then we think, oh, did we go the right direction going there? Shouldn't we thought about it before? So let's start with John this time, because I think he's going to give us a very different view. John, the floor is yours.
Well, I think that indeed the issues that we have of what gets used when and where is one that is the most important one. And we've already touched along a number of the issues that are around, which include, basic human rights like being able to walk around and not be monitored. And then there are the other issues that are, say, how do you do a certain amount of credentialing? And I think that the biometrics can be used in some places to establish, say, for, a payment system that you would use for a digital identity across the network. And that is a very different thing than when we are using them in public at broad scale, where accuracy and other issues, along with the basic human rights, come into play. And that's really, we do need to decide what we really want to be building before we build it, and what the legal and other implications are first before we deploy it.
Nama or Adam or Sebastian, do you want to respond? Or
Actually, I like to share, to add an element of thought in this discussion about privacy. I mean, this is an essential question, and whether it is too late now to think about it, I think it's never too late first. But just I'd like to highlight a paradox, right? We're talking about privacy, all data which are in systems, identity systems. But for me, a large part of it, of prevention, or how to address these ethical questions, is education in reality. Because the paradox is that we have a lot of people using social media, right, and posting online their own selfies willingly, right? So these people haven't checked they haven't checked the terms of service of the platform they are using, but they are giving away the data to various companies in the world. They can be based on many continents with different applicable laws, and they are giving away their data. And then at the same time, we have a public discourse of people are wondering, I mean, are worried about the rights and about privacy of the data which are in biometric systems. And although the purpose is slightly different, essentially, there is an education problem behind, because in one case, people give away their data because they see a benefit of the service they are using, because it's cool to share the pictures with your friends, or I don't know. And they don't consider, because they're not probably educated or informed about all the risks and where all this data goes, essentially to train AI systems. So I find this paradox quite intriguing actually, and I will be happy to hear more about, to hear about the opinions from others on that.
I think I heard Nema several times responding to such discussions about faces and people's preferences. Nama, would you like to answer?
I don't know if I have anything smart to say to Sebastian around that, but I think that if we look at modalities of biometric modalities, I would say that the paradox that you've presented is, I think it's amplified to the maximum when we talk about facial recognition. Because if we look at other modalities, our fingerprints, our iris, gaze, all the other modalities that are used in some scenarios, I would say that most people would find them to be something to hold back and not to share it. But our faces is something that we all see on the street. They are apparent, they are out there. Except in Iran, maybe, or other places for women. But basically, it's out there. Our faces are out there. We share our images in really stupid apps that we when we want to see how we look when we grow older. We share those when we go abroad all the time. I don't know if all of you know, but when we cross the border, every border control person can see our image, and it's probably is being stored. This is like a basic process today. So it's a question if are we really that concerned around our private facial image? On the other hand, when we look at big databases or huge databases, this is a concern. It is an asset that you can use to monitor people, to search people on the street. I really don't have a solution around that. I think this paradox would continue to linger around facial recognition. And I don't think it's that apparent when we look at other modalities. So basically, I would say if I'm looking at myself, I would say that my my face image, it's not a secret. You've just posted our webinar online. My face is on it. The other speaker's face is on it. If you Google my name, you would find a few pictures of mine. But as a government, a database of the entire population is something to look after. It's something that you have to manage. So I don't know, quality, quantity makes the quality. There's a saying in Hebrew, it's not translated so good into English. But I don't think there's a solution to that paradox. Sorry.
Thank you. Thank you for that for that interesting discussion. We have a few questions from the audience, and so let me present these questions in turn, and I'd like to request one or two of you to respond. The first one, if either Sebastian or Nama could respond. The question from Aurel has to do with databases. You have government databases, you have private company or commercial databases consisting of, say, fingerprints. The question is, what would happen if these commercial databases were hacked? Is there a way to deal with impersonation in the event? Let's say a very large database of users is hacked, and then this is used to impersonate existing users in government systems. That is the first part of the question. The second part of the question, perhaps John could help us with this. Will the way to solve these problems be through legal measures? For example, prohibiting commercial companies from collecting biometric database of users, or can there be other approaches to resolve this issue? So I'll open it up to the panelists. Please go ahead.
Okay, so I'll try to answer the first question. And the first question is the risk. What is the worst case scenario? What can happen if a database is penetrated and then biometric data is stolen, right? So and then the question was mentioned, the government database, but run with commercial system operated by the government. So the question is, which form the biometric data is stolen? So if it is the raw data which is stored, like raw images from faces or fingerprints, which is the worst case scenario, and which is unprotected or protected in a very loose way, and that the protection can be broken and the images can be stolen, then that's a worst case scenario. If we are in the scenario where we don't have raw data which is stored, but templates which are which are protected, which is, I would say, more recommendation nowadays is to not to store raw data, but protected templates, hence the field of biometric template protection. Then the risk is going to be mitigated. Now, in the worst case scenario, which is the worst, if data is stolen, well, if data is stolen, data is stolen. You can make fakes. You can make injection attacks directly by bypassing the camera system, by doing injections directly of the same data. And if it is the exact same data, you can detect it if you do injection, if there is no change. But if you can use it and to make an artifact, a fake biometric, then well, you are in trouble. So the only way is that you put in place some mitigations in order countermeasures to detect presentation attacks. So there is this is the reality.
Yeah, thank you, Sebastian. And once if that is done, I'm assuming the techniques that you and Adam have developed for presentation attack detection can actually be invoked as well.
Exactly. These are the countermeasures exactly. So you need to put in place presentation attacks detection.
Right. Thank you. Thank you, Sebastian. John, did you have a comment on the second part about the legal measures that can be put in place?
Well, I think that from a cybersecurity aspect, one of the things that we know most about large databases that have attractive things in them is they will be hacked, they will leak, they will end up either in the hands of another large entity like, you know, a company or a country, or it will be available publicly. And the idea that such a database can be held secret in private is not, we haven't seen a case of it at all. So the assumption is going to be that if you have a large database, it is going to be hacked. And I think that that brings us to, yes, we need to have some sorts of development norms, regulations, laws that dramatically limit when these things are being constructed, because they will inevitably go through one way or another. I mean, we've seen it with even the DNA companies like 23andMe and the whole saga around where that data is going. It isn't a technical computer cybersecurity hack, but the company holds attractive data like a DNA database, and then, oh, they go bankrupt. I mean, you know, that is essentially a hack on the system that isn't what we normally think of, but the effect is it goes away somewhere. And the long-term effects are that these large databases are valuable, and so there are people who are going to want to buy or steal them.
Excellent points, John. And I think the problem will only exacerbate as these data sets grow larger in size. And if there are no constraints on what can be stored and what cannot be stored, and what is the lifetime of these data sets, I think the problem can be exacerbated even further. But thank you for your comments. I'll move on to the next question, and I apologize if I interrupted someone. Did I interrupt anyone? Okay. If not, there are 4 questions that Vasily has asked, and I'll pose this in turn. Going to begin with the question on soft biometrics. And Nama, if you don't mind, if you could field that question. So the question is as follows, concerning soft biometrics like internet surfing patterns. It seems the sample might be much larger than standard biometrics modalities samples. I think Vasily is referring to the fact that the feature vector length could be much larger than, say, a face feature vector. So how to develop such system to make it fast enough to be usable in a real life scenario while preserving privacy at the same time? So if we were to use soft biometrics along the lines that Nama, you had suggested, is there a way to make it usable in real time?
Well, that we would have to see. I mean, soft biometrics could be all kinds of modalities or artifacts. This is something that could be developed. Actually, I didn't imply that this is something that we should do. I am just seeing that happening before my eyes. I mean, that because of that digital scenario that we are all in. That depends on the soft biometrics that would be used. But I think that the advantage of soft biometrics, the way I see it, is not around not only the amount of time that is needed to be for that to be applicated, but also the fact that you can use it throughout the session. It's not a one-stop shop. So this is the main advantage of that. It's not like, okay, I've recognized you, I did the one-to-one match, you passed the gate, please go further. This is something that that one can use throughout the session, making sure that nothing was switched in the middle, that the person is not different now, and also for verification purposes. And this is something that would be developed on as much as verification that you would do in that system, then the system would could collect information about your digital stuff, and that would be more accurate. Hence the problems or the challenges I presented before. So I'm not sure this is the concern is around that it would the approach would be much more complex than just to use one item around that process. I hope I gave some answer to the question.
Thank you, Nama. That's very interesting, and certainly that perspective is also equally important. And so we appreciate the input. And I must say at this time, if for any of these questions, if other panelists want to respond as well, please feel free to let me know. But I'm moving on to the next question, but you must feel free to introduce your comments as well. Vasily, I'll come back to your questions shortly. I'd like Adam to respond to this. The next question, this is from Itai. Do you think that biometrics have a limit? Do you think it will be reached? And if so, AI will be able to, I'm assuming it's trying to fool us, I think is what you meant, Itai, and we won't be able to overcome it. So basically the question is about the limits of biometrics.
And the question is what these limits are. Limits of accuracy, right, or speed, or well, I think that the limits probably come from more from information theory than our computational capabilities, because they are growing. And I think Rich Sutton wrote a bittersweet lesson and said that basically all the advancements that we see are because of the constantly increasing computational capabilities. It will grow, and we will be able to compute what we want probably very shortly. The question is about the limits. The question is how much information we can extract from our body and behavior, and probably this is where the limit comes from. And to me, and I'm hoping that Aaron will agree with me, that probably some resurrection of multimodal biometrics would be great, because we're focusing on iris, we're focusing on the face, and we're trying to make them all individually very, very strong. But I would I would probably risk a statement that every single part of our body and also to some extent our behavior delivers some individual features with different discrimination power, but they are not fully complementary, of course, right? But if we put them together, we can get a really strong system that is resistant to including some types of spoofing attacks as well. And because we have now this deep neural networks and everyone is fascinated by these black boxes and we have a lot of GPUs, I think this is actually coming. So instead of that is one of my crazy ideas, and maybe it's not that crazy these days, that we can actually train a giant neural network as we see all these GPT large language models, a giant neural network that will be just looking at us, how we behave, how we look like at different resolutions, right? I think that Nama mentioned fusing iris or extracting iris and face in one shot. Well, maybe we can do more in one shot. And this one shot, maybe not only just an image, it can be a video or some other type of observation that we can do. And then this giant black box, right, with some structure, of course, right? So transformers have some structure, so it's not like completely fully connected multi-layer perceptron, but with some structure. But still, giant neural network will figure out how to extract these signals, how to combine these signals, and how to translate the signals into a very strong biometric method. So I'm not sure if this is the answer to the question. I think the limits come from what we can extract, how much information, individual information, we can observe. And it's not related to computational power, which is, as I said, stronger and stronger.
Thank you, Adam. And again, if any of the other panelists want to chime in, please feel free to do so. Well, why don't I move to the next question? Sebastian, could you field this one from Vasily about cancelable biometrics, which can be used to reset an identity? But also the second part has to do with the FHE encryption, how to utilize it, especially when you need to perform one-to-many, one-to-million, or one-to-billion real-life comparisons. What are your thoughts on the practicality of these technologies?
Right. So maybe for the morphic encryption part, it will be better to let or answer that one. But on the first one, on the cancelability, right? So this is related to this concept that we can somehow revoke a biometric template, which is stored somewhere, like we'll be revoking a password, let's say, or any other credential. So in practice, you cannot you cannot revoke your biometric. You can revoke a digital a biometric template which was stored at some point because it's associated with a key or with some form of encryption. You can revoke that one, but doesn't mean that you can revoke the associated biometric, which is actually attached to your body, right? So the problem is that when we want to do this kind of, we want to revoke that biometric because this biometric has been stolen. So my fingerprint has been stolen. So you cannot revoke your fingerprint. So that's the thing. So if you want to have a secure system, you need to, by design, you need to put in place multiple technologies and safeguards which ensure that you have biometric template protection, which is in place to mitigate the risk that if the data is stolen, no raw data, if data is stolen, then it will be very, very complicated to do something with it, especially to make a presentation attack with it. Then in addition, if you have a BTP technique which have these properties of cancelable biometrics where you can basically revoke a biometric template that has been stored, in which case you can replace that one, plus combine with a presentation attack detection technology that will prevent that if the biometric data has been stolen and used to create an artifact, then it cannot be used to create to presentation attack, and then that you cannot use it to attack a system to impersonate. Then you are going to have a secure system if you consider all those aspects. Okay, but just looking at isolation, just solving the problem or addressing the problem by putting in place some form of cancelable biometrics is not going to solve completely the problem. Now, homomorphic encryption, and then this will be transition for OR, is one of the techniques that can be used to do, let's say, to do comparisons in cipher text, so in the protected domain. So whether all the computations can be done without having to unencrypt, to uncipher the data, decipher the data, which is currently the case at the moment. At the moment, you compute, you transform biometrics into a feature-based representation, a fixed length representation, and you use some form of distance to compute the distance between two vectors, and this is how you compute the score. So homomorphic encryption is all similar techniques are ways to bring some privacy and guarantees to avoid leaking information by doing computation in an encrypted form of the data. Now it comes with a price to pay. Of course, there is no free lunch. Right, and this comes with essentially storage and computation, extra computation, and then for all extra details and another view and more pertinent view and understanding on the problem, I prefer to leave the floor to Or if he wants to take that question.
Thank you. I will intervene even though I'm not one of the panelists. But for one-to-one, we've just recently with Margarita Osachi from our department and the student of ours, Eliron Rechimi, we've shown a way to extract the feature vector given just the binary outcome of the comparison. So the system, assuming that we have the capability of doing injection attack, we're capable of reconstructing the facial image. Again, as a standard in academic papers, there are terms and conditions, that there's no rate limiting, and that you're allowed to do injection attacks of a sufficient amount of queries. But for many systems, this seems to be working. Again, terms and conditions apply, and I guess that future works will, of course, improve that aspect. Going back to the question about doing identification of a person out of a database, I would like to go back to what John said, which is, what are you trying to achieve? Why do you want to protect the identification, right? You have a facial image of one person that you have a database of encrypted identities, and then you have another identity that you need to compare to this database, which is a very time-consuming process. But the question is, what is the problem that fully homomorphic encryption tried to protect? Whether it's the release only of the database, if the database leaks, so we can do other things, probably, for example, using multi-party computation to distribute the trust and revoke things and shift things. And actually, there are multiple methods to deal with that, or do some secret sharing, or we can handle this way. Or do we want to add fully homomorphic encryption because it's cool and it's the new technology, in which case I highly recommend using post-quantum security measures, adding some AI into it, machine learning, and put it on the blockchain. I think I missed one of the buzzwords, probably. Yeah, so the question is what you're trying to solve with the fully homomorphic encryption of the identification problem. Again, as an academic paper trying to do something to prove that it can be done, yes, it can be done. I think that one of your colleagues, Sebastian, is working on that, right? And I think it's doable, right? From technical perspective, you reach the point it's doable. The question is only, as usual, why?
Thank you, Or. And Adam, thank you for answering many of the questions via the chat. I really appreciate that. So you can see the responses that Adam has provided in the chat box. I'd like to direct this next question to John. John, in the biometrics community, and in fact in AI, this question comes from Vasily. So in the biometrics community, there is an onus on explainability. For the system to be able to explain its decisions, not merely produce a number or produce a crisp output, there needs to be some kind of explainability. So the question is, do you agree that there should be regulations and industry standards that will force the companies developing large and especially publicly available AI solutions to make their results explainable? What are your thoughts on that? Will that mitigate at least some of the concerns you had expressed earlier on, or would this be a whole different beast to deal with?
I think that they are similar, but not the same at all. When we're dealing with AI systems, there are a variety of things that we want to know, including, how did you come up with that, which is frequently a useful thing to know on its own for the reasons like when we talk to somebody else, you want to have another person explain to you how they came to a conclusion, and that's really useful. And this is it's good to have that, but it 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 has its uses when, say, a biometric is being done for certain purposes using certain identity vectors that you might want the recognition system not to tell you just, yes, I think that's 90% chance, but I think it's a 90% chance that there's a match for these reasons, and those would be useful for some of the civil rights and other purposes that we want to be able to use it, because we demand this of other humans. And if we're going to make a machine that we're going to replace a human with, it has to at least live up to the same sorts of things that we would expect a person to do. So I think that it is useful, but it again comes back to the why are we building this system and what do we expect it to be doing? And when we build systems based out of even reasonable fears and reasonable things that are essentially an unsolvable problem, sometimes you actually make it worse by making things be more accurate. Because if somebody comes up with a way to do a presentation attack to spoof something, that the humans behind something will accept spoof because, oh my God, there's a 1 in a billion chance that this could have been wrong. So therefore, we know that this spoof is not a spoof. And that's sort of the paradox there of more accuracy doesn't necessarily mean better. It could mean more fragile.
Thank you, John. Nama, would you mind taking this next question? Because you had a very nice slide. There were 3 use cases in the wake of 9/11, and you spoke about different modalities. And Elad's question is, what would you say is the most interesting biometric modality that is not yet investigated? And why do you think it has high potential, and why was it not yet researched? So even in digital ID and or in border control systems, do you have any interesting thoughts on that front?
I would say that there are 2 modalities that I would presume that would be maybe more used but are not. I would say the first one is iris. I mean, iris is a very highly it's a modality that was researched throughout the years, but because of IP reasons, it wasn't very vastly used, and it's not vastly used up until today as well. I mean, we've seen some of the there's a new initiative by Altman around iris, and that could be we could see that happening in the next few years, that we would see the iris being more and more used. This is something that could happen. This is the first one. And the second one that I would say, there's the modality of veins. I mean, we've seen veins around banking a few years back, but we haven't seen any peak around that. And that is also something that could emerge because of fatigue around other modalities, or usage over and over with facial recognition and other modalities that would make us turn to additional ones. I would say these are both the two modalities I would look into. But this is really like a hunch. I'm not sure that I'm right. I do want to make one remark around the things that we've heard before about revocation of templates, and that around biometrics, there are many conflicts that we see when you look at operational and privacy and R&D, and there are conflicts all the way. And one of the conflicts that I would like to emphasize is around that when you manage big systems around, population, I mean, a vast majority of the population, you can't usually use only templates, okay? And this also connects to the fact that you have to explain your results, explainability. You have to have a person in the loop. This is also around the regulation around the GDPR and AI Act. You have to have a man in the loop. A man in the loop cannot look at templates, cannot look at something that is encrypted. He has to look, he or she would have to look at the image. So and these are basically the systems that you are worried the most. These are the big databases, the ones that you want to be protected. So we're around this kind of paradox that on the one hand, you have to have these databases and to manage it. And on the other hand, you can't only use templates because you can't really investigate if you have a problem. So I'm not sure that revocation is basically something that we can look at as a significant tool around preservation of privacy, maybe in small applications, but not the big ones. This is something I'd like to emphasize. So.
Thank you, Nama. I think your comments around the vasculature system as a biometric is indeed interesting, especially in banking systems and such. And I think your comments on Iris is well placed. While Iris has been researched for multiple decades, I think its deployment has been rather constrained. So seeing the success of iris recognition systems would be interesting in the future. Thank you. I'm going to pose this question to Sebastian. I know we are slowly running out of time. So Sebastian, if you could briefly address Michelle's question. Adam has already provided a response as well, which is he correctly points out we do have testing methods for PAD and injection attacks. But he says, but I think we lack testing standards and benchmark to test PAD systems. So what are your comments on that, especially since you have been extensively involved in not only organizing competitions, but also testing in your own labs, many different technologies. What would you say to that question?
I would say it's untrue. So actually, there are not only there are plenty, I mean, there are standards, there are data sets which are publicly available, there are methods, there are metrics describing the standards, plus there are implementations that exist open source in many places, in several places, including in our lab. So I would say the operational capacity to perform tests in PAD exists. Now, it may not be equal for all the biometric characteristics. That's true. So, I mean, it's more developed for face and fingerprint than, let's say, veins, right? But it exists. So there are certification schemes that exist. I mean, there is FIDO, there is Android as one, and probably the others I don't know. So these schemes exist. They took inspiration from the ISO standards to develop these schemes and the norms they have to fulfill in order to be delivered a certificate. So right, so plenty of people are fully knowledgeable about these type of technologies. I mean, several people here around the table, and Stephanie in the US, Stephanie Shakers also, that's been deeply involved also with discussions with FIDO years ago. So I'm not saying that everything is solved and that there is no progress to be made. Probably some harmonization in those techniques, or in even creating more data sets which are larger and covering more types of attacks. But I mean, there is a lot that exists.
Thank you, Sebastian. And Michelle, I think he's still here. Or did he log out?
I'm here. I'm here.
Michelle, I wonder if your question also had to do with the fact that this is a cat and mouse game, right?
It is.
Attacks keep constantly evolving, and sometimes we don't even know what kind of attacks are on the horizon. And Sebastian, do you think that problem has been addressed through standardization and testing, or do you think there is still some room for addressing that fundamental cat and mouse game scenario?
Okay, so definitely, yes, there is room to address that. And as I was saying in my opening statement, the testing, it means that it should be the job of, some organizations, or all the researchers collaboratively to share this knowledge about finding new ways to attack systems and communicating around it in order for people to include that in the inventory of attack vectors that needs to be documented, that needs to be replicated, that needs to be used during testings, doing testing. So definitely, yeah, it's a continued effort.
Thank you, Sebastian. So Michelle, looks like you can do your second PhD, or is it your third PhD? I forget who's keeping track now, but that's a very interesting perspective.
Thank you. Yeah, it is a cat and mouse chase, and we need to think about it.
Yeah, thank you. And I must also acknowledge when we talked about FHE and the good responses from Or and the others, that we also have another expert, Adi Akavya, from the University of Haifa, who's also with us. And in the past, she has given some excellent lectures on this, very accessible lectures on this topic. Or as we were winding down, so shall we pose the final question to our colleagues in the panel, or did you have anything else to say before that?
I'm pondering whether to ask a question about the Orb by Sam Altman's AI company, from ethical, practical, and privacy reasons, versus to allow the panelists to give a concluding remarks before we end this meeting. What do you think is the better option? Provocation or settling down?
Or the floor is yours.
Okay, let's provoke. You let me moderate things, you're going to get provoking. So I've heard about this new thing which is going to solve all the problems of biometrics and identification, the Orb by Sam Altman's company. And I know that Sam Altman is doing only things which are for the best of humanity. So I would be very happy to conclude with hearing your thoughts about how we're going to solve all the problems of identity with the Orb. Who wants to start? Who wants to start? John?
I'll start. From a practical standpoint, we have already seen with his system the problems that you would expect to see with it. They include people who register for it, then sell their identity to somebody else who uses it for profit. That already has happened. And it has already happened with large numbers of people who were in poorer countries that just said, yeah, sure, I'll do that. And then somebody contacts and says, oh, can I use your identity over here? As an example, we say this is inevitably going to happen. It's already happened. It's already doing that. So The other larger aspects itself, it's already getting the errors and then the knock-on effects of what you would expect it to do. So I'm going to start with that and then say the idea that you would have a private company doing things that were payment, etc., money-making operations based upon non-revocable biometrics is just such a bad idea. From the very beginning, it's a really good thing to say, here's another reason why this is a bad idea.
I'm sure Sebastian has looked into presentation attacks against the orb, or can probably tell us something about that.
Actually, yes and no. Actually, no, but I love to. So, because the first time I heard about it, I dropped them an email asking for a copy of the orb, and I'm sure that Adam will love. I mean, maybe Adam is more lucky than me and managed to get one. I don't know if he's still around, but I would love to have one to play around with it. So I don't have any answer. I've never been able to see the device, but I would love to have one. But for me, this looks like a big Logitech camera from the old days. You know, this sphere camera that was capturing faces, but now it's capturing an iris. So that's always the question: where is the data? What is used for? So that's like a that's almost like a phone where you give your selfie iris to a company. Yet again.
Okay, thank you. And Mar, probably you're supporting the use of it in governance and in identification, right?
John said it's a bad idea. I won't say it's a good idea for sure. I would say first, if you just go back a bit and look at the bigger picture, this is just another example of how the big techs gain a much bigger and stronger power if you compare them to governments. Okay, this is a process that has been happening for the past 2 decades or so, and looking at it, I think this is just another example. If you look at Meta or Google or all those companies, the revenue, the way they conduct themselves. It's maybe in a few years it's going to be the governments would be of Meta and so forth, and Google, and the governments of the people would be much weaker entities. I don't know. This is my dystopic comment. Still, if I look at it in a more practical view, first, I've said before that I think iris would be something to look at, and this is an iris project. I do believe you can cheat anything, so that won't be a bulletproof project for sure. If you can falsify anything, you would falsify things around iris as well. Question is, what would be the application for it? And it's yet to be seen. We don't know yet. Also, maybe this is something that would make more government feel more legitimate to collect more modalities or iris, and they didn't feel it before, but now if Sam Altman is doing it and everybody is pitching in, so what would government think around that? That's a comment for you or around government. This is my 2 cents.
Okay. Any concluding remarks from panelists? After we bashed the orb, hopefully. It was clear that this was not planned, by the way, for the recording and everyone. We did not plan in advance to bash the orb. However, it seems like we can either bash it or TC shell it. Concluding remarks, if you want.
I would say this. Okay, I will continue. This would be my concluding remark. When I started to work around biometrics 14 years ago, it was so and so. Okay, we knew about fingerprints. Facial recognition was not even that developed back then. The other modalities were just beginning to emerge, or halfway through. And it looks like this biometrics is here to stay. Just referring to the question that is there a limit? I think it's here to stay. I think it's an anchor that we will continue to see. It's just that it's more and more complex. It's more and more challenging. The aspects are much more, there's a variety of aspects that we haven't seen before. So this is my take on the future of biometrics. More challenging, more complex, here to stay.
I support that closing statement.
John, you have the opportunity to say something different, or
No, I'm going to agree on it that there are just a lot of things with biometrics where there are good uses for them, and there are places where they are completely the wrong idea, and it's a matter of where they're used for what that turns it from something being completely okay to why are we doing this? This is a disaster waiting to happen.
Like the orb.
Yeah.
Well, excellent, excellent comments. Thank you to the panelists for fielding these many questions. I think your perspectives are very important. I know Adam had to leave, but we are grateful to his input as well. Do you have some closing comments as we wrap this up?
so I would like to thank all our panelists. Thank you very much for spending this time with us and sharing your knowledge and experience with us. I would also like to thank all the speakers of the school that we had over the last meetings, and of course many thanks to Arun for helping and organizing this. I think I couldn't do it without you, obviously. And I hope that everyone will get to meet in person next year when we will run the 4th edition of the school. Hopefully this time in person, in the peaceful and quiet time.
Hopefully, yes.
Yes.
Hopefully. Thank you all.
Thank you. Thank you very much.
Thank you. Stay safe.
Thank you very much.
Thank you,
Bye-bye.
everyone.
See
Take
you.
care.
Thank you, everyone. Thank you so much.
Take
Thank
care.
you.
Bye-bye.
Thank you. Bye-bye.
Bye.
Thank you
Thank
for
you
a
all.
wonderful course, Or and Arun.
Thank
It's
you
really
all.
good.